Hello everyone, thanks for coming to this session. Just a quick check here on the title. I'm going to talk about empowering AI innovation through open geospatial ecosystems. So just to make sure you're in the right talk. And my goal is to actually kind of introduce you to Overture's mission of enabling interoperability for maps and location data, and then explore what this means for AI and particular LLMs. Also a warning to the audience, right? Most of the stuff you see around here is open source code. This is about open data. Just so you know. Okay, quick background. I've been in mapping and technology for more than a decade, and most recently at Google in Silicon Valley. I moved over or back to Europe about a year ago, and now I live in Berlin, which makes for a really convenient trip over to Amsterdam. That's awesome. And I lead product for Overture. I'm going to talk all about Overture. And given my background, you will probably understand why I'm so excited about this kind of shift that we're trying to make happen and that we're on in the approach, in how we approach geospatial data. Now, about Overture. It's a foundation within Linux, and it was started in 2022 by AWS, Meta, Microsoft, and TomTom for companies who are in technology and mapping. And the mission is to create reliable, easy to use, and interoperable open map data. And interoperable, you will hear a lot, interoperability. I will explain what that means. At a high level, Overture has a few main components. There is map data, which is what we're primarily known for to many. Actually, I wanted to do this. How many of you have heard about Overture before? Raise your hands. All right, about 1/3, and particularly the people that work with us. That's cheating. Okay, so we have map data. That's why it's called Overture Maps. And we have quality control and validation for this map data. But then we also have an ID system. And this ID system actually identifies real-world objects with unique IDs. And that is the backbone of interoperability. And I'll explain that even more. So who are we for? It's our ecosystem. This is developers who want to build apps and need map data. It's for developer platforms who want to build APIs and SDKs and need map data. And then also for data providers who have their own data, might be proprietary, not open, but who want to sell it into the market better and to more people. And as I said, we're governed by the Linux Foundation, which is really cool because that allows us to collaborate together between a lot of the companies that make Overture, which you see here. So when we started, we were only 4 companies, the 4 I already mentioned, and then Esri joined us as one of the leaders here in Overture soon after. But what you'll see is our members, they represent a wide range of industries, and in even industries as transportation, mobility, automotive, just developer-focused companies who are trying to put together developer products, or analytics and geospatial analytics, GIS companies. Also some with a very clear social or sustainability focus. And let me just say the focus, the momentum, the growth has been pretty amazing. As I said, started late 2022, so haven't been around for even 3 years yet. So there's a lot of growth, and in my mind, what it shows is there is an industry consensus that foundational open map and location data that we do is a pre-competitive shared asset in the industry. Companies seem to agree on that more and more. Great. So let's talk about why we're doing this. And there is an interesting problem here. I call it more data, more problems. Because if you think about it, there is more geospatial data available than ever before. think basically connectivity plus sensors in some way. People walking around with smartphones, connected cars driving around, even drones or satellites or everything has proliferated. And the key problem is that most organizations have used their own identifiers and their own conventions for the same data, for the same real-world data in our case. And this means anyone who's building an app or who wants to run analysis on data has to spend enormous resources just to stitch everything together, and there are quality issues with that. If I had to compare it to open source code, it's like a bunch of companies all building the same fairly basic code, isolated from each other, and that code doesn't talk to each other, that code is incompatible to each other. So more data here really comes with more complexity and more cost, and it's really hard to integrate. We call it the data conflation tax. It is the costly matching and rematching of the data and of integrating new data. So I have a quote here, which is from one of the big tech companies that are part of our leadership team, who are saying, I'm spending more on integrating data than on licensing it. That's really problematic for an industry. And particularly because this was a big company saying it, smaller companies are even more burdened by that. Also, I want to talk about AI innovation, and there's impact there as well. Just a couple of weeks ago, I was at a Geospatial conference where there was a leader of a research lab up on stage, a research lab that engages in geospatial data, and they do agricultural research, including with AI. And he said, we spend more than 90% of our time on integrating geospatial data and only less than 10% on the actual innovation. So they've tied up all their resources in making this work. The end problem here is when the innovation suffers, then the users suffer. So to summarize, we've already established the mapping space is very siloed, very inefficient, very fragmented, and it has lots of inconsistent data. And at Overture, we address these challenges in a collaborative way. We have all these companies working together, this diverse group of members that I showed you. And by bringing together these resources, these experts in Overture, we create an open map that enables data set with any type of spatial context to now actually talk to each other. How does this work? This is my favorite slide. I said I lead product, so these are my 2 products at Overture. Very simple. First, we have the reference map. And the reference map, that's the anchor for our reference framework. It is really the foundation for data matching. I'll explain that too. Then we have the reference framework, and that is the absolute key to interoperability. And it acts as the conflation shortcut. It allows data sets to connect efficiently. The foundation for all of this is these data layers that we're making for geospatial data themes. So for these, now I can go through them, but for these, our focus is really on making them robust. High coverage, meaning you know all the real-world objects, completeness, and freshness, so they're up to date. What we don't do is richness. We don't want to know everything about all these themes. This data is often already commoditized in the industry, is oftentimes available openly already, but not in the way that we package it and standardize it. We have currently these 6 themes available for download openly, free. Just wanted to highlight free. And you can see there's a transportation theme which has more than 300 road segments and connectors. That's how it's organized. Our biggest data theme, or one that gets a lot of traffic, is the buildings theme. 2.3 billion buildings. That is very, very high coverage. And then also I want to highlight the places data set. That's interesting because places are basically businesses or under other POIs. And for that data set, we have a permissive license, meaning this is open for any use, no attribution requirement. And it's a very unique data set out there. Microsoft and Meta have made their places data open. And I mentioned that in particular because it's very relevant for AI innovation. And I'll chat more about this in a bit. Great, so our data sources that we use are existing open data sets, crowdsourced data, government-provided data, AI-generated data, data provided by our members. And what we do is we conflate and deduplicate the data, we validate it, and we make it ready for consumption. Now, I talked a lot about interoperability and wanted to explain how that works. It's, Overture has open data, but if you think about it, it's a means to an end. The real value is in the interoperability we are creating. And interoperability is based on our reference framework, we call it. And the reference framework is called GERS. That's like when you think of a bear or something. It's Global Entity Reference System. And what GERS does, it assigns IDs that are unique and persistent to real-world entities. And GERS is basically a reliable way to refer to features we have in our reference map. So if it's a building, if it's a place, if it's a road, it has an ID, you can refer to it. You can match any data set that has the same real-world object to our data set and assign the ID back to your data set. That's how interoperability is created. It's a very simple concept. It allows any type of data to be anchored in our data, in our IDs, be it other open data sets or commercial, proprietary, secretive data sets that can live behind whatever firewall. GERS then, after it's been matched, it acts as the conflation shortcut, where there is no more rematching the data. It is just integrated. Let's look at how this works in practice. I have a couple use cases here. The first one I'm going to skip for a second because we're going to go into that much more deeply. But then smart cities you see up there. We have a member, Esri, who works a lot with municipalities, cities. And cities and municipalities can use GERS, our reference system, to match their disparate data sets, bring them together, maybe public works, emergency service, anything local, to a single authoritative view. I also put AR here, but it's really, it can be smartphone, it can be AR. When billions of users search for businesses, they explore local areas or restaurants or tag locations in posts. They are using our location data already. And GERS provides the stable IDs to anchor these interactions so that they can be used in a consistent way across, as I said, traditional formats or AR in the future. And then for automotive, TomTom is an example, our member who basically uses our stack and anchors all of their rich data layers on top of our base map. So they're putting, I think I showed you this visual here, this was actually for automotive, right? They're putting road signs and speed limits and they're putting the traffic and lane details and even, smart driving features, ADAS features, autonomous driving features on top of that map. It's all anchored. Great. So now I'm going to double click a bit more on travel, which is, an industry that has very high ecosystem complexity, I think I could say. I have Stu here from the Open Travel, the executive director of the Open Travel Foundation. I'm looking in his direction because he just gave a talk on the complexity of travel and the data friction there. One key challenge in travel is that there is no common language for location, and so basically a hotel chain, a booking platform, a ride-sharing company, they could all have different IDs for the same hotel or property. And this forces everyone in the industry to constantly translate, manage, or reconcile data. And that's very slow, and it kind of it's a problem for the companies and the users. And so it can break the user experience. And in my mind, this is a good example of the conflation tax in action. A lot of industries have that. Travel is an example. And I think what all these industries have in common is that they have different participants within the industry use different sources of truth, and particularly IDs for the same things, for the same real-world objects. For example, places data. Our solution is to provide this missing common language. GERS assigns a unique persistent ID, as I already said, from a hotel to a rental car station. And this creates a foundational and open source of truth that the entire industry can use and build upon. Also, we are not asking anyone to basically throw out their data and swap it out and only use ours. We have a concept called bridge files that actually allows, it's just a match between IDs. It allows people to keep using their own IDs, but they now have a robust way to refer to our IDs, and that connects them to the ecosystem. Eventually, this then turns a complex data science problem into an actual, you could say, database column join. So it becomes ideally rather simple to do that. Okay, to turn this vision and into reality, bring this to life, I wanted to announce, and we had a press release earlier, a very exciting collaboration between Overture and the Open Travel Alliance, soon Foundation. And Open Travel is the leading open specs and standards organization in the travel industry. And what we'll do together is that we will bring GERS as a universal identifier for location and properties to the travel industry and make it available there. We'll also align our Overture data definitions and the Open Travel object models. And I want to show an example, a collaborative example, what this could actually look like for a traveler. So it's for me, this is very special because we're a data platform, so I'm not demonstrating consumer use cases a lot these days. Great, so what I said already, the current ecosystem, highly inefficient for both actually travelers and businesses. You can see travelers spend a lot of time looking for the right travel, I think visiting more than 40 pages on average, it says here. And then hotels spend up to a third of their revenue on user acquisition, right? And these are symptoms that are driven by fragmentation in the industry. So together, Overture and Open Travel can enable the ecosystem to overcome this. We are combining GERS, our IDs, with an agent-to-agent standard protocol for communication. GERS will basically provide the stable identifier, the discoverable identifier for location. Think of it as like anchoring a hotel, for example. And then agent to agent, the protocol provides the common language for AI and for AI agents to communicate. And this creates a direct connection between a traveler looking for, a specific offer, and a hotel having an own AI agent who can answer questions that this traveler might have. And as Jan from Open Travel says here, it's kind of, a business without a discoverable agent will soon be as invisible as a hotel today without a website. That's the assumption. By the way, Jan is one of the people who built the demo that I'm going to show from the company InHotel, and they are an Open Travel member, so you can already see there's a great collaboration. Awesome, and this is what it looks like in practice. So I'm first going to show it on slides real quick, then I'm going to try to do it in real time, and you can give me some questions what I should ask the agent. Just creating the backup here first. So travelers can now discover and then engage directly with GERS-enabled hotels and their agents on a travel platform, and this works on whatever travel platform they're already using. Here, a user asks if a hotel, the distance to the palace is walkable, and the agent knows the answer. Great. Another example here is this model allows very specific entry points for conversations. So you'll see here that a user goes to the on-site restaurant category, and a specific agent pops up that can provide highly specific responses. The user asks about a kids menu, and the agent gives a lot of details about it. All this is grounded as a AI technical word in the hotel's own valid information. Great. So let me try this. Okay, I hope. So this demo is provided by a couple different companies. I would like to highlight this was built by InHotel, and then it happens, and LinksRes, and it happens with Hilton Hotels on the website, and it uses basically Overture's places data on the back end, and links it all together through our IDEs. So this is like a travel booking website you just saw on my screenshots. And now you have an agent that is associated with this hotel's IDs and therefore discoverable. And opens up a window. And in our example on the slide, we said, is the palace walkable? And let's see how good the internet connection is. And it works. And it's workable. No surprise there. Any other questions you would want to know about the Waldorf Astoria Versailles? A very prestigious. Yes, please. Question made just slightly more complex. the question is, how do you know how to get there and how long it actually takes to walk? So this is an agent that was built on a rich corpus of information provided directly by the hotel, right? So if I ask something, there's a qualitative data source behind this, and it's not a geospatial engine that runs that. However, it is totally possible to build that, right? So for example, like one of the partners here, AWS, if you use AWS's stack, they have functions like they can calculate distance, they can calculate different things like walking directions, and then the agent would be able to surface that. What you need to do is basically have a service on top of the data, and the agent, triggering that service. Totally possible. This one won't do it. It will tell us roughly the minutes because it might have that in the rich qualitative information that it's been trained with or been fed with as this RAG. So yeah. Great question. Is it biased towards the hotel is the question. This is basically the hotel owning the corpus that basically the retrievable information that this agent uses. So yes, if the hotel wants to bias that information, they could. That said, it really depends on how this agent is orchestrated, right? It could also they couldn't just be take Overture data, right? If the qualitative corpus behind us from the hotel has incorrect geospatial data, you could also ground it with Overture data and correct it in the response. So there are options to validate basically the response. Cool. And I think then we have the deeper flow here as well. So if I view the hotel details, I can go and ask questions about the on-site restaurant. And I really like non-alcoholic cocktails, so I gave it a run last night, and I said, do you have non-alcoholic cocktails? And they do. And can I order it to my room? By the way, it also shows, because it's RAG, it also can pull the direct reference and show the actual underlying hotel provided information through a link. And here I can say, yes, you can also do that through room service. I also asked it my favorite question that I never get answers to without calling the hotel, which is, can I order my deliveries to this hotel and receive it there? And this is a very easy way to find out. Right now I'm always calling hotels to know. Great. Awesome. So now I'm switching back. All right. Sorry. I told the person in the corner that this is the moment when it will fail. And it does fail. All right. Okay, back to the presentation. Okay, so this, what I just showed, creates something we call reverse discoverability. And so basically by including the GERS, yeah, go ahead. Sorry, I didn't see your question. Great question. The question is, do you also have access to real-time data? this is a great question because, and I'm going to go into the concept in a bit. But imagine, so AI is trained on data, right? And in the training data, it might know something about a hotel or locations. But what if but then the training data is typically outdated by the time the user goes into this agentic kind of flow. What if there, for example, is a weekly menu at the hotel that changes? Like how would the agent know? So that's the benefit of RAG. And so you can basically provide changing real-time information about a hotel or a restaurant to the agent. But then the question becomes, how would the agent know that this is the right weekly menu for this exact hotel or restaurant? And that is where you need the GURS ID. You need a clear identifier. And so one of the use cases that I see for AI and for LLMs particularly is the benefit of that common identifier that you can use in order to get, permanent information about a place that can come from Overture Maps, our data. You might have trained on it already, so it's already there. But then pull in real-time data because you have the identifier, and a hotel can provide that real-time information tied to that ID so that the agent would know, okay, this is definitely the right hotel, this is the right information, and I can basically enrich my response with the weekly menu. Go ahead. Yes, and so the question was, what about events? There's a lot of thoughts on events, but basically the question I would have is, how do you anchor events? Do you anchor it to location, a place, a building, and so forth? When you know that, it's great. You can anchor the event to that ID, and you can make it discoverable. Now, I actually foresee as part of so what we've seen, and this goes way beyond the presentation, but what I'm seeing about AI and LLMs right now is that we are moving from very, very general capabilities into very use case specific ones. I actually believe there will be APIs very specifically for events and ephemeral information, locally bound ephemeral information that anyone who's building an app who wants to pull in event data can then use. And the challenge, again, back to my original problem statement, will be, how do you conflate that to the map? How do you conflate that to the real world experience? And if you have something like IDs or entity bound connections, that makes it a lot better, a lot easier, and avoids errors in the LLM processing all the way to the response. So yeah, I do think events are a very, very interesting problem statement for this. Yes. Okay, just doing a quick time check. I think I have 7 minutes. That's great. I'll just keep going. So this is a slide I didn't include in my upload. You can find the presentation on the website, right? And because I thought maybe like some people find it contentious, but it's interesting, right? The use case I just showed. Why is this important? Well, user behavior is changing. So instead of using search for travel, they're now using other things like LLMs, right? So a little bit of a volume decrease there. And so as users are increasingly finding this type of information through AI, LLMs, or other channels, our mission at Overture is to enable the best map. But what does the map really mean? It is kind of how is geospatial data being consumed. So that in my mind, this really expands our mission to also enabling the best AI and LLM experiences. And that's why I was so keen to share this today. Great. And now we go back into what I just started to discuss. Because with that context on the, we looked at travel, but it's really about industries and AI in general. There is already a lot of use of geospatial data, and particularly for two key application areas, right? One is training, because in order to argue and reason about the real world, an LLM would need to be trained on real world data. It needs to kind of get that grammar. And then there is grounding, and this is probably the even more important use case for applications. We just demoed one. In order to make LLM responses really useful and trustworthy, connecting what the LLM wants to do to an actual source, a real-world source, verified facts, is very important. And so we see both of these capabilities come together in the typical conversational LLM kind of use case that we showed today, and then where it's been trained on a level of knowledge, and LLMs have all been trained on OpenStreetMap, Overture, and other real-world data already, but then also has a way to tap into that real-time information that we just discussed, right? Like the rich data, the weekly changing menu, the events. And I'm super excited about the role that Overture can play in this, because there are a few benefits of being open and having open data for this specific use case. There is the legal ambiguity, right? People love permissive data sets. Our places data is fully open for commercial use. You can just train your LLM on it, no problem. There is, for grounding, there is our data is open. You can verify it. You can see why did the LLM respond in a certain way. You can see that source directly. And also to your question about bias, right? It's open, right? So people can check which source should be used in the response, and maybe we should verify the response by using an open data set. Great, and then yeah, I can't say it enough. GERS anchors this thing together, the interaction, different agents, different places, rich data to this. It creates consistency through the ecosystem. It also makes sure that when an AI learns about a place, that over time it doesn't lose that connection. More knowledge is coming in about a place, I can relate it back to the place. I don't lose that connection. Great. So what I hope you all take away from today is that Overture is building more than a map. And we are actually building an open and shared understanding of the real world, and it's machine readable, and you can use it. And in my mind, it has a lot of potential and is already powering AI and the future of AI. But this can only be achieved together as a collaboration, so I invite everyone to join us to build this foundational asset for the AI industry together. And for developers who want to start to explore and build with Overture, we have a bunch of resources here, a lot of documentation. We even have a new GERS landing page, which I should have included here, but if you check it out, you will find more information why this is so powerful and how you can get started, how you can onboard your data to GERS, or how you can work with commercial companies who will help you onboard your data to GERS. And that's it, and I have 1 minute left. I'm happy to take another question or two. Yes, please. Question is, what's the business model of TomTom these days? Now that they're no longer selling navigation devices for the car as much as they used to, and now that Overture Maps is fully opening and commoditizing the underlying base map. And the response is, this is great because TomTom, as I showed, is one of the founding members of Overture, and they have made a decision, right, that the base map is no longer a strategic monetizable asset for them. It is a commodity. They don't want to deal with making this in a duplicative way, just like every other company who makes a map or stitches together a map in the industry. Instead, they want to collaborate on that. They want to share that asset so that they can focus on what they believe are richer, more valuable layers on top of that base map, which is the speed limits, which is the ADAS functionality, the routing, the menu and hours for businesses, things that Overture doesn't do. We focus on very basic attributes that allow people to match data sets together. So for a place, that is the place name, the address, the lat long, the category, but not the menu, the rich data, the ephemeral data. That we don't do that. We focus on identifying the entity itself so that we can create interoperability. We can allow people to match data together. Sure. How does someone who has proprietary data with own IDs ensure, or how can they use Overture, and how do they make sure that the IDs don't collide? I think you said. So the power of having an open, basic, foundational map with IDs is that someone who has proprietary or secretive or whatever data that they don't want to get anywhere out of their firewall, they can just download our data, use it to match it against their own behind the firewall, use our IDs, and they can relate all their proprietary data to our IDs and continue to do that in the future. They don't ever need to go outside of their own system, but they get the benefit of us organizing this foundational information and keeping it fresh and keeping track of, oh, does this place exist or not? Oh, does this road exist or not? They no longer have to do that. They're no longer in the business of maintaining this basic map layer. The question is, how does Overture work with OpenStreetMap or other open efforts? Some people also provocatively say, what's even the difference between OpenStreetMap and Overture? Yes, there's a follow-on. Slightly different question, but good question too. How much time do we still have? -3 minutes. Okay, first question, OSM. 40% of our data comes from OSM. roads, for example. A lot of roads come from OSM. Buildings, some come from OSM. I couldn't go through all of it. We are a consumer of OpenStreetMap as we are of many other open data sets. And what we do is we conflate between the best sources. We want the best open sources. We conflate, meaning we sort through and deduplicate and clean the data. We support OpenStreetMap. We sponsor events because we really like the data and we like the community. And yeah, we're just, I could say, I could exaggerate a little bit. OpenStreetMap is really a community of map creators. They care about mapping the world. Overture is really a community of map consumers. They care about making the map as easy to consume and packaged as a data platform as possible. And so we kind of build on top of OSM to a large degree. And the other question was, how do you conflate if you have multiple versions of data? For example, one source might say this road exists, another might say it doesn't. Well, that's a really tough challenge because first off, what is reality? What is the ground truth, we call it in mapping? There is no map is 100% correct. So you have to find rules and mechanisms to update the map and keep it fresh. For some themes, we have a priority of sources. We know which sources are generally better than others, so that's how we decide. That's not the smartest way. For other themes, we actually start to do something very sophisticated we call using signals. Our members can contribute signals. For example, they had a recent interaction with the business. They know the business exists. That helps us put together something we call a confidence score, which is our expression of how much we believe between all the sources we have that a place exists or doesn't. So then we give the user the choice. How high do they want to set the bar for their consumption use case? Cool. I think now I'm -5, so better stop. Thanks for the great questions. Really appreciate it.